got to get hooked up here. Okay. Can you all hear me? Okay, great. Let's see if we can stick this on one of the pockets. Okay. Need a glass of water. Thank you for coming. I'm used to small, intimate seminars. So let's try to make it as much like that as we can. I'm actually hoping that you'll ask questions even as we go along, especially afterwards, but even as we go. The last 20 years has seen some remarkable developments in cognitive science, and there are three I want to talk about tonight that are particularly important. The first is that the mind is embodied, that it arises from the body. It's not just instantiated in the body. It is shaped by our bodies and brains and our physical experiences and our social and interpersonal experiences. Second, one of the major results of cognitive science is that most thought is unconscious, not in the Freudian sense of repressed, but just not accessible to consciousness, below the level of consciousness. The third is that most abstract thought is metaphorical, and I'll explain what that means in a while. Those three results contradict all existing philosophy. It's kind of staggering, but true. I've just finished a book with my colleague Mark Johnson, who's chair of philosophy down at Eugene, on this. It's called Philosophy in the Flesh. And what we did was ask the following question. What would happen if you started with the empirical results and then constructed the philosophy to fit those results? It's real different, and I'll give you some sense of that difference tonight. But let me start back about 20 years ago to give you some sense of what these results are and why they're important. I hope you don't mind my walking around. I'm kind of nervous. I could sit, but that's all right. And I probably will in a while. What I like to do is sort of stand behind chairs. It's a little protective. Back in the late 1960s, two of my colleagues, Brent Berlin and Paul Kay, did work on color. They went around the world checking out how people spoke about color and what their color categories were. And they had started with a traditional view of color. The view was that each language has different color systems, and they can be as different as you like. And it's known that English, say, has basic color terms, 11 of them, red, blue, green, etc. Some languages have fewer than that. Most of them have fewer than that, and some have only two. The Dani have two, light and dark, Mili and Mola. And what they did was they asked the following question. Instead of going around with color charts and saying, what is the range that the terms give you, they said, give us your best example of this color. They found out something remarkable. For example, when they did fieldwork on Tarahumara in Mexico, which doesn't distinguish blue and green, they said, give us your best example of this, call it GRU. And they didn't give aquamarine. No one did. They gave central blue or central green. This happened in language after language. In Dani had two colors. You ask for the dark color, give us your best examples, and you get central blue, central black, and central green. Ask for the light ones, you get central red, central yellow, and central white, people varying, but not putting things in between them. Eleanor Roche did a remarkable experiment with the Dani. She tried to find out whether those speakers could learn a color system like English, and whether they could learn an arbitrary color system where you just break up the spectrum any old way. Turns out the speakers could not learn the arbitrary color system at all, but they could learn the color system of English perfectly with the right central colors. The question is why? And that question lasted until the mid-1970s, when Russ Develoy, also a colleague at Berkeley, figured out basically how the neurophysiology of color worked. We have three sets of color cones and neural circuitry that goes through the LGN and back to V4. And they respond, the neural circuitry responds to, one circuit responds to red and green, one to blue and yellow, and one to white and black. And then they, of course, they can go at once. So if you're seeing orange, you're seeing a red curve and a yellow curve, and where they intersect is central orange. In short, the central colors are given by your body. Moreover, the structure of color categories is given by your body and brain. Color categories have structure. There is deep red, light red, orangish red, purplish red, and so on. Lots of shades. That structure is given by those neural response curves. You may think that these flowers are red, that the red is in the flowers. It's not. The flowers reflect wavelengths. The red is in the interaction between those wavelengths, your color cones, and your neural circuitry. You create that red. It's remarkable. It's true that the flowers are red, and false that the color red is in the flowers. Flowers are red relative to your creation of that color. Now, we have a color system that has three dimensions: hue, saturation, and brightness. There are monkeys who have a color system with 4 dimensions, and we're colorblind relative to them. There are birds with color systems of 5 dimensions, and we're doubly colorblind relative to them. Their systems create other colors that we can't even conceive of. It is not the case that when you say the flowers are red, you're fitting the words to what exists independently in the world. The redness is partly created by you. What is even more remarkable is that the same is true of things like chairs and cars and tables. Eleanor Rosch and Brent Berlin, again, did some remarkable work in the mid-1970s. What they did was this. Rosch looked at expressions, words like car versus furniture. Car versus vehicle, or chair versus furniture. Superordinate categories versus what she called basic level categories. Now, you might think they're pretty much the same, they're just different levels of categorization. But chair and car have very special properties that furniture and vehicle do not. For example, close your eyes for a minute, get a mental image of a chair. No problem? Now, get a mental image of a piece of furniture, not a particular one, a generalized piece of furniture. Not a bed, not a chair, not a table. You can't do it. Okay? Get a mental image of a car. No problem. Now get a mental image of a generalized vehicle neutral between cars, boats, trains, planes, rockets. Can't do it. You have motor programs in your body to interact with chairs. You're using them right now. You have no motor programs for interacting with generalized pieces of furniture neutral between chairs, tables, beds, and so on. Part of the meaning of chair, part of what defines the category of chairs that includes these chairs and this chair and barber chairs and electric chairs and beanbag chairs, part of that has to do with the motor programs you use for sitting in chairs and interacting with them, and your mental images and your Gestalt perception. That is, you and the chairs jointly create the category of chair. Chairs, as a category, are not just out there in the world. Now, when I went to graduate school, a while back, I was taught when I studied semantics that the meaning of a sentence like the chair is brown is given by the following conditions. That the object referred to by the chair is in the set of chairs in the objective world independent of any people. And moreover, that object has to also be in the set of brown things independent of any people. There is no set of brown things independent of any people, and there is no set of chairs independent of any people. That theory of meaning has been disproved by cognitive science, and you contribute to truth. There's another very dramatic set of results that came up. These all came up in the mid-1970s. This one was prompted by a remarkable linguist named Leonard Talmy, who was at Berkeley at the time. He's now director of cognitive science at the State University of Buffalo. And he looked at what are called spatial relations terms. In English, they're prepositions like in, out, through, under, above, below, in front of, in back of, and so on. Now, various languages express these in various ways. No two languages has the same set of spatial relations terms with the same meanings. They differ very radically around the world. It's quite extraordinary. Let me give you an example of how radically different they can be. There's a language called Mixtec, spoken around Oaxaca in Mexico. Has a few million speakers. Lots of dialects, lots of varieties of Mixtec. In Mixtec, there are no prepositions, no cases, no postpositions. All spatial relations terms are given by body part metaphors. Think about that. What could it mean? Suppose you want to say, the cow is standing on the hill. You say, the cow is standing the hill's head. You project your body onto the hill. Now, suppose a plane is flying over the hill. You project the space associated with the head up here. You say the plane is flying the hill's head, and it's flying through that space. Now, we have a word like on. Here's a glass. It's on the table. On has three components of meaning. It's vertical with respect to the table. It's in contact with it, and the table supports it. Mixtec has no word for on, no direct concept just for on. If you want to say the cat is sitting on the roof, you say the cat is sitting the roof's animal back. It's horizontal, like a cow or a horse's back. If you want to say the cat is sitting under the tree, it's the cat is sitting the tree's foot. If you want to say something like the cat is sitting out in the field, you project the face onto the field, and the cat is sitting the field's face. This even works metaphorically. If you want to say John is working in Bill's place, you say John is working Bill's face, that is, in his place. Okay? Now, we also use body part projections for things like in front of and in back of. For example, here's a bottle, or here's a glass. This glass has no front and no back in itself. We put it down. Relative to you, the bottle is in back of the glass. You have projected onto this glass a front and a back with the front facing you. It doesn't work like that in all languages. In West African languages, it goes the other way. There, the bottle would be in front of the glass. Okay. What's happening is spatial relations are things you are projecting. Now, one of the remarkable things that Talmy did in studying spatial relations around the world was that he showed that they could be broken down into a small number of primitives of primitive spatial relations that were the same in all languages. A remarkable feat to accomplish. And these primitives include three types. First, there are things like in and out. They're defined by bounded regions in space. Okay? Now, what is true of a bounded region in space? If you take a boundary and you squiggle it around and you stretch it or contract it, it remains a boundary. It remains bounded. Namely, it preserves topology, but it doesn't preserve size and shape. The same is true with a source, a path, and a goal. If you have a path with a source and a goal, you can squiggle the path around and stretch it, make it long or short, and it remains a path. Preserves topology, doesn't preserve shape or size. There are a whole bunch of things that are like that. Touching, for example, is like that. Preserves closeness. However, there are other primitives that have to do with not topology, but bodily orientation. Front of, back of, up, down, etc., where you're projecting your body onto something. There are still other primitives that have to do with force, with how your muscles work. For example, support. Here, with on, you have all three. You have verticality, orientation, touching, topology, support, which is force. All three of those have to do with your body. They're not out there in the world. Fronts and backs don't exist out there in the world. If the bees are swarming in the garden, that enclosure where the bees are is created by your projection of a boundary on the garden. What's remarkable about all of this is that we constantly use spatial relations terms all over the place, and they're coming out of our bodies. Now, how do they come out of our bodies? How do they come out of our brains? Well, there's been a remarkable study by Terry Regier, who's now a professor at the University of Chicago. He has a book that came out this year called The Human Semantic Potential. He was one of our grad students at Berkeley. In fact, he was our first real cognitive science graduate student. Excuse me. And he took up the following problem. What are primitive spatial relations concepts neurally? In terms of our brains, how could a bunch of neurons characterize a concept? That was the question. In order to approach the question, he took a project. The project was take a computer screen with a bitmap, a bunch of dots, and put on it shapes, circles, squares, etc., in various spatial relations, above, below, give a sequence of them so they can go through and around and under and so on. Okay, now give to the computer in letters words accurately describing these relations in one of 6 languages. The 6 he took were English, Arabic, Hindi, Russian, Chinese, and Mixtec. The computer has to learn, on the basis of just positive examples, what the conceptual system is and what new cases will be. That is, it has to correctly label new examples in the languages given. He solved this problem, and he solved it in a remarkable way. The first thing he did was a failure. He took what is called PDP connectionism, simple neural models, circuitry models, of the sort that are used in things designed by Remmelhart and McClellan. That is, simple models of neurons connected, but not with any particular structure other than layers. That could not solve this problem, and it just can't do it. He then did something more interesting. He had studied neuroanatomy and psychophysics. And so he took structures that were found in the brain, and he noticed something interesting about them. There are a set of structures called topographic maps. For example, in the visual field, in V1, primary visual cortex, back here, The neurons that come out of the retina are connected through the LGN back to parts of the brain. In the other side of the eye, you have the corresponding neurons are connected right next to them in ocular dominance columns. These connections are not one-to-one. They don't just preserve pictures, but they preserve topology. That is, connections that are next to one another here are next to one another back in the brain. So Regier made up models of topographic maps in layers, connected in the way that people have found them to be connected in the brain, with what are called receptive fields. And what he showed was that when you look at topographic maps and you hook them up to connectionist learning systems, you can learn the topological concepts, like in and out and touching. He then observed that Hubel and Wiesel had found that there are cells in the brain that respond to lines oriented in various ways. So he added models of those orientation-sensitive cells and discovered that his program could learn the orientational concepts, like up and down, front and back. He didn't get to the force cases. Now, it's still, he only had one dissertation. It's hard enough. What is incredible about this is that these spatial relations concepts characterize reasoning, spatial reasoning. A very simple example. I have here a container, a bounded region in space. I put it inside another container. Call the inner one A, the outer one B. I put an object X inside A, you know it's inside B, just by looking at it. Now, that inference is an inference that has its correlation in logic. Categories are understood metaphorically as containers, and there is a principle of logic called modus ponens. Socrates is a man, all men are mortal, therefore Socrates is mortal. That is, Socrates is in the category, container, man. Man is in the category, container, mortal. Therefore, Socrates is in the category, container, mortal. That form of reasoning is built into your physical brain. Remarkable. Remarkable because when I grew up and went to graduate school, I was taught something really different. I was taught that reason was transcendent. It transcended the body. It wasn't bound by the body. That reason was part of the structure of the universe. That logic had to do with the structure of the world, not the structure of the brain and the body. What we're learning is that reason arises from the structure of the body and the brain. And that is truly remarkable. Let me give you another example of the sort carried on in the same project at Berkeley. Jerry Feldman, my colleague at the International Computer Science Institute, directs what he calls the L0 project there. The most recent work has been on motor control and on concepts like hand motion. For example, what can you do with your hand? Well, you can grasp objects, pick them up, move them to left and right, pull them, push them, knock things over, do all sorts of things. Lots of things you can do with your hand. The question is, could you get a computer to learn all the verbs of hand motion in a given language for an arbitrary set of 5 or 6 languages? Corresponding problem that Regier took up, but for verbs of hand motion. It's a hard job. It was undertaken by David Bailey, who is now finishing the dissertation on it and has solved the problem. What he did first was find out that somebody else at the University of Pennsylvania had gotten a computer program that simulated the body, every bone and muscle. So he said, okay, we've got a body here. Let's hook it up. And let's show on a screen hand motions, doing things, and label them in various languages, and ask, what would it take for the computer to learn that? That means it has to learn all of the relevant distinctions of what a hand can do in any language. And secondly, to make sure you learned it right, you have to give it an instruction and have the computer carry it out, have the simulated body do it. In order to do that, you have to have a theory of motor control that's at least fine enough to characterize the distinctions among all the verbs in the world, but also carry out the right physical operations. One of the things that he noticed as he was doing this was the following. If you look at the languages of the world, you find a bunch of expressions in grammar called aspectual expressions. They're called aspect. Things in English like John is running versus John has run. Aspect marks the structure of events, the way we understand the structure of events. And in the languages of the world, certain aspects are marked. For example, John is picking up the glass means he's in the middle of this process. John has picked up the glass means it's completed. It's done. John began picking up the glass means he's at the beginning of the process. John stopped picking up the glass meant he interrupted the process. John picked up the glass again and again meant he iterated the process. Okay? Those kinds of distinctions show up in the languages of the world, sometimes with endings or affixes or something. They also show up inside the basic meanings of verbs. If I take a word like tap, that's iterative. I do it over and over. If I take something like pick up the glass, that's completive. It has an endpoint. If I take something like walk, it's continuative. It doesn't have an endpoint, and so on. So to learn the verbs, you've got to learn the internal aspect of those verbs. It turns out that the theory of motor control you need in order to learn the verbs and have it pick up the glass and do all those things happens also to characterize the internal aspect, the event structure of that verb. And it turns out that exactly the same structure that does that characterizes the external aspect, which characterizes our event structure for every verb in the world. Aspect, our structure of events, comes out of motor control. Amazing result. We understand events in the world because our bodies are structured to understand them that way, because we move that way. Now, another remarkable set of results that have come up recently, recently being in the last 20 years or so, though these results are really recent, they're in the past year, has to do with metaphorical thought. And metaphorical thought, up to about 25 years ago, was seen as contradictory. People thought that there was no metaphorical thought, that metaphor was in words. If you go to the dictionary and look up metaphor, it'll give you Aristotle's definition, that metaphor is a matter of words, poetic language, or especially rhetorical language, and that words in metaphors are used not in everyday language at all, and moreover, they're not used in their ordinary way. They're used in an inappropriate way. That is, they're taken from one domain, but they're applied to some other one on the basis, Aristotle claims, of similarity. It turned out Aristotle was wrong. It took 2,500 years to find out. Let me tell you how I found out. In 1978, almost 20 years ago, I was teaching a small undergraduate seminar at Berkeley. There were 5 students in the class. So we got to know each other very well. 5 wonderful students. We sat around the table and we read papers and talked. So on the day that we were to discuss a paper on metaphor, one of the young women in the class came in looking really distraught. She was in tears, just trying to hold back her tears. She sat down And we had our papers out. We were discussing this scholarly paper. And after about 2 minutes, she said, "I'm sorry, I just can't do this. I've got a metaphor problem with my boyfriend." She looked around and said, "Maybe you guys can help." Well, it's Berkeley in the 70s. We all said, "Sure." We formed an instant support group. We all knew how to do this. And she said, "On the way over here, my boyfriend said that our relationship has hit a dead-end street." She said, "I don't know what this means. It's very upsetting to me." So we said, "Hey, look, if it's hit a dead-end street, you can't keep going the way you've been going. You may have to turn back." And then we realized that there were a whole lot of expressions in English in which love is conceptualized as a journey. For example, the marriage is on the rocks. It's off the tracks. We're spinning our wheels. It's been a long, bumpy road. We're at a crossroads in this relationship. We're going in different directions. We may have to bail out. Now, when we looked at these expressions as linguists, we're linguists, what do linguists do? Linguists look for generalizations about language. That's our job. Okay? Nobody else does this. Only linguists do this. So we sit around looking for generalizations about language. We said, hey, there's a generalization here. You're conceptualizing marriage, not marriage, I mean love, in terms of a journey. What are the lovers? They're travelers. What is the relationship? It's a vehicle. Where's the vehicle going? Well, it's got a destination. What is that? It's your common life goals. What are the difficulties in the relationship? They're all impediments to motion, things that keep you from going someplace. So they're being on the rocks and off the tracks and, dead-end streets and crossroads and so on. Getting stuck. So we looked at this and we said, hey, that's a pretty neat generalization. The woman got furious. I don't care about your generalizations. My boyfriend's breaking up with me. He's thinking in terms of this metaphor. Aha, we said, that's an interesting question. What does it mean to think in terms of a metaphor? That's what happens when you're in a linguistics class. Well, we said, look, what do we have? We have a mapping from the domain of travel to the domain of love that's systematic. Travel is mapped onto lovers, vehicles onto relationships, and so on. How could you reason in terms of a metaphor? Well, maybe what you're doing is taking your knowledge about travel, using that systematic projection to map it onto love. So we tested it out. We're spinning our wheels in this relationship. What are the wheels attached to? Are they attached to a clock? Nah. They're attached to a car. Is the car moving? No. Are you putting any effort into getting it moving? Do you want it to be moving? How do you feel? Frustrated. Everybody knows the answer to these questions. Now, suppose you take that knowledge about cars and travel and you map it onto love. You're saying the vehicle, the car, is your relationship. And it's not going anywhere. It's stuck. And you're trying to get it to move on toward common life goals. You're not making any progress in this relationship. And you're putting effort into it, and you're frustrated. That's what it means to be spinning your wheels in a relationship. That is, you reason about love in terms of what you know about travel because there's a systematic mapping, a projection of the ontology, the entities in the travel domain, travelers, cars, destinations, and so on, onto the love domain. And that mapping maps knowledge as well and allows you to reason about love in terms of travel. Now, being a semanticist, that's my job. Whoops. I shouldn't hit this. Being a semanticist rather than an engineer, I noticed that this was a contradiction to the classical theory of meaning. Not just the classical theory of metaphor, which it was also. Notice, in the classical theory of metaphor, there's no metaphorical thought. Here, where is the metaphor located? It's not in the words, it's not out there in the world, it's in your mind. You're thinking metaphorically. So Aristotle wasn't right. Metaphors weren't just in the words. In addition, when I went to graduate school, I was taught that meaning was the relationship between words and things in the world. But here was something very meaningful. You were understanding love in terms of a journey, and that was not in the relationship between words and the world. It was in your mind. You're understanding these things metaphorically. You were thinking metaphorically, and not only that, you weren't aware of it. We think metaphorically as part of the cognitive unconscious. Now, there's nothing strange about the cognitive unconscious, and let me back up a bit and tell you about that. Whenever you're in a conversation, most of your thought is unconscious. If you think about everything you need to be understanding, thinking about, and so on in a conversation, think of you're listening to me now and I'm talking to you. It is not the case that I know what the end of this sentence is as I'm saying it. I may be saying something and have no idea when I start to say it how I'm going to wind up, but somehow I'm going to finish it. Not only that, you don't know how it's going to wind up, but somehow or other you have to bring to bear your knowledge of the phonology of the language, its sound structure, and all the rules of sound, your knowledge of the grammar of the language, of the words of the language, the context, and everything else you know to understand what I'm saying. And you can't be doing that consciously. It's mostly unconscious, like 95% at least unconscious. And you do this all the time. What we as cognitive scientists do is try to figure out what the cognitive unconscious is. Exactly. What are the principles of phonology, grammar, semantics, pragmatics, discourse, and so on, and metaphor that go on in the cognitive unconscious? That's what we do. Now, in the many years since then, it's been almost 20 years, the theory of metaphor has sort of burgeoned. There is a huge amount of study that's been done. We asked, how many of these are there in English? The answer is thousands. We asked questions like, are they ever the same across languages? The answer is lots of times, but not always. For example, love as a journey is not universal. There are many cultures where love is not a journey. Now, it's important to understand why. In order to have a metaphor that love is a journey, where there are common life goals, you have to have life goals. That is, you have to have a culture where there's a purposeful life. Well, what metaphors allow you to conceptualize purpose? What is purpose? Well, there are a number of metaphors. Here are a couple. One is that a purpose is a destination. It's a place you're getting to. So that's why they're called goals, and they're goals you can reach. Achieving a purpose is reaching a goal. You see the light at the end of the tunnel. You're almost there. Okay? There are others. For example, it could be getting a desired object. You know, you had the job in your grasp and it slipped through your fingers. Okay? Now, when you look at this, let's take the purposes or destinations metaphor. In cultures that have purposeful lives, you're supposed to have destinations in your life. You're supposed to know where you're going in life. You're supposed to have direction in your life. Otherwise, you're floating around with no direction. That's not a good thing in this culture. You're supposed to be on a path toward something. And in fact, you have to have documents to show where you are on this path. The documents are called CVs, curriculum vitae, the run of life. What is a good CV? It shows you're making appropriate progress in a certain direction toward a goal, toward your goals, at the right time. What's a crummy CV? Well, you did a little of this and a little of that, and you don't know quite sure what you're going to do next, but maybe you'll do something. Okay? If you have a purposeful life, that's good. If you don't, that's bad, this culture. Love as a journey assumes that the two of you have purposeful lives and that they have to be put together, that you have to have compatible destinations. That's part of that metaphor. That's why you have a love as a journey metaphor here, but not in lots of other countries of the world. There are lots of countries where there are no purposeful lives and no metaphors for purposeful life. Okay, we've now studied hundreds, thousands by now, of these metaphors in various languages. Let me give you some more examples. What is time? How do you conceptualize what time is? Well, there are certain fixed metaphors for time. For example, time can be a moving object. So the time has come. The time for action has arrived. The time is passing. Time is long since gone. Okay? Where is the future relative to where you're standing? Where is it? Future's ahead. Past is behind. In English. There are other languages where that's not true. There are languages where the past is in front and the future is behind. It varies. Now, times can be coming towards you. You speak of the flow of time. Why is it that Tuesday follows Monday and that Monday precedes Tuesday? Here's Tuesday. Here's Monday. They're coming toward you. Tuesday is following Monday. Which way is Monday facing? Got to be facing towards you. So its back is here, so Tuesday can be following it. You project onto times, you project faces, fronts and backs, which is why you can face the future confidently. Why you can meet the future head on. Now there's another very general metaphor for time, which is very much like this, except you shift figure and ground. Here, the times are moving and you're standing still. In the other metaphor, you're moving and the time is the ground you're moving over. That's why you do things over time, on time, within a certain span of time. You can have long times and short times. Things can come down the road. Okay? Now, how do you know that you're really conceptualizing time this way? Well, there are 10 sources of evidence, and I'm not going to give them all, and there are lots of experiments. But let me give you a simple case to show you that it's not just words. Consider first two sentences. Easter is coming up on us, and we're coming up on Easter. Same words, come and up on. In one case, you're using one metaphor, Easter's coming here. The other case, we're going there, Easter's over there. Same words, the metaphor's not in the words. The words have to do with motion. In both cases, come means the same thing, motion, metaphorical motion. But the metaphors are different, and that's what gives you the difference. Suppose someone tells you, hey, let's move the meeting ahead a week. Which way do you move it? It's ambiguous. If you think of it in terms of this metaphor, here's the meeting. You want to move it ahead, you got to move it here. If you think of the other metaphor, the meeting is here, you got to move it there, in opposite directions. Don't tell anybody to move the meeting ahead. But there's a point to this. The metaphor isn't in the words, it's in your conceptualization. The word ahead means ahead metaphorically in both cases, but the metaphors are different. Now, why does this matter? Why should you care? Suppose you're a scientist. Okay, people think metaphorically, so what? Can you think of any metaphors in science? For example, take the metaphor that time is a spatial dimension. Can anybody think of a scientific theory where time is a spatial dimension? Anybody hear relativity? Where you have space-time. Time is a spatial dimension. In general relativity, not only is time a spatial dimension, but there's no gravity, no force. The force of gravity is curvature in space-time. You've all seen probably these drawings. The drawings go like this. You got a basketball and a rubber sheet. You put the basketball on the rubber sheet, it pulls the rubber sheet down. You shoot a marble across the rubber sheet and it goes in a curve, as if the basketball were pulling it toward it, but you know it isn't. It's just going around this curve. So if space is curved, it will look as if there's a force of gravity, but the curvature of space will achieve that. Now, Einstein observed that light, photons, have no mass. So if photons were going past a large object with a lot of gravity, like the sun, the question is, would they bend as they go around the sun? Well, if they have no mass, they shouldn't bend, because the sun can't pull it if you have a force of gravity. But if space is curved, they should bend, even though they have no mass, because there's no force pulling it there. Space is curved. The experiment was done, 1919. They waited for an eclipse of the sun when you could see a star. They knew where the star was supposed to be normally when the sun wasn't, then that's part of the sky. You have the sun there, the light rays come by, and they're off by a certain angle. The light has curved. It looks like it's there, it's actually here. And the light has curved. In fact, almost exactly what Einstein predicted. So people said, aha, we really do live in a four-dimensional universe. Time really is a spatial dimension. There really is no force of gravity. Space is just curved. It's a little funny. Think about what it says. Okay? I take this glass of water and I drop it. It'll fall down, but there's no force pulling it there. Rather, it has followed a geodesic in space-time. A little funny. I mean, we understand the world in terms of forces, but maybe Einstein's right. Maybe it just followed a geodesic, right? I mean, suppose I trip and I fall on top of you. Okay, I was just following a geodesic in space-time. I jump on you. Sorry, geodesic. Now, of course, no physicist would use relativity to compute these things. But that's what, if you take the metaphor literally, Einstein's metaphor, it says there's no force of gravity. Now, let's think about what else that metaphor says. Suppose you have a curvature in space-time. Well, in order for space-time to be a spatial dimension, it has to extend. That means at the present, the future has to exist. It has to be there. It's extending. The past has to exist. If there's a curvature in space-time, look at the points on the curve. Suppose you're at one of those points. The other points on the curve that are coming have to exist. If you take Einstein's metaphor literally, it says the future exists now. It sounds deterministic. Now, what Einstein did was absolutely incredible and remarkable. He took our ordinary metaphor system, in which we understand space in terms of time, time in terms of space, and he understood force as curvature, and in that metaphor, he was able to use Riemannian geometry, one single mathematics, geometry, to formulate a single unified theory. And it works for a huge number of cases. Moreover, one of the interesting things about metaphor that makes it important for science is, as we saw, metaphor preserves inferences. Metaphor preserves reasoning. If you have mathematical inferences about one domain, they get carried to another. If you have a mathematics of space, they get carried on to time and force. He used the mathematics of Riemannian geometry to be able to calculate things in terms of time and force. Truly remarkable accomplishment. Is his theory literally true? It doesn't have to be taken that way. It can be seen as a metaphor that is a remarkable metaphor. It allows us to understand the universe in a different way. It allows us to use a single mathematics, Riemannian geometry, for doing these calculations. However, if you take it literally, it has these weird consequences. The future exists at the present. You know, you drop a glass and there's nothing pulling it. It's just hit a geodesic in space-time. You do not have to consider these scientific theories as literal. If you don't, what happens? You can still get all the same consequences because metaphors preserve inferences about what you can measure and what you can manipulate. You get all the same consequences, but you don't have to take seriously that the future exists at the present, and you don't have to take seriously that when you drop the glass, nothing pulled it. Now, what about more recent theories? Take superstring theory. You're all familiar with superstring theory. Let me tell you a little bit about it. Let me give you the 2-minute version of superstring theory, very, very simplified version. What superstring theory does is generalize what Einstein did. Einstein said, look, let's get everything understood in terms of space so we can use geometry, the mathematics of Riemannian geometry. Now, normally before this, when people talked about particles, they talked about properties of particles as if they were possessions. It's a common metaphor, properties for possessions. I have a headache, right? I got a headache, the headache went away. The noise gave me a headache, the aspirin took it away, right? It's possession. Properties are possessions. He has blue eyes. This particle has spin plus 1. That particle has charge. It has charge minus 1. Okay? So properties are conceived of as possessions normally. But they don't have to be. We have an alternative metaphor that states our locations. So consider the difference between I have trouble and I'm in trouble. I'm in trouble says there's a region, and I go into it. I got into trouble, got out of trouble. I'm in a depression, I got out of the depression. Okay? States are regions, and changes are motions into and out of those regions. Causes are forces that move you into or out of them. Like the home run threw the crowd into a frenzy. He drove me crazy. Okay? Now, in superstring theory, what you do is change the metaphors. Instead of saying the particle has spin and charge, you say the particle is located at a place in a spin space and a charge space. However, there aren't too many values for spin and charge. You have, 5 values for spin and 3 for charge. So these are very narrow spaces. Not very many locations there. Now, for ordinary space and time, they extend hugely. So to characterize a particle, you have to say where it is in space, where it is in time over large regions, And then where it is in the spin space and the charge space, but they're very narrow, you get strings. Hence, and you get multiple strings, hence superstring theory. Now, what is the move here? The move is to have all of the physical entities be conceptualized using spatial metaphors, so that you can apply the same mathematics, Riemannian geometry, to all of them. What results is you have to have at least 10 dimensions. Now, is it true that we live in a 10-dimensional universe? Only 6 of them are real small. Real small. Is it true? Well, depends on how you think about it. If you accept the metaphor, it's true. But you could say, hey, it's a pretty good metaphor. You can use the Riemannian geometry for all of that stuff and maybe unify all this. They haven't done it yet, but great, let them try. Terrific. Magnificent metaphor. Science uses metaphor. Maxwell's equations are an example. Nancy Nersessian, who's a remarkable historian of science at Georgia Tech, is the country's expert on Maxwell. She's read through all Maxwell's papers, and she found that Maxwell used 2 metaphors, a sequence of 2 metaphors in coming to his equations. He had a lot of friends who studied fluid dynamics, and he used the metaphor that electricity and magnetism are fluids. And then he took the equations from fluid dynamics and applied them to electricity. But how did these guys get the equations for fluid dynamics? Well, they had these vortices. What do you do with a vortex? You say, aha, it looks like a wheel. And you take the mathematics for wheels, and you get the mathematics for vortices. Metaphor is at the center of physics. Now, it's also, by the way, does this say that the physical theories aren't true? No. Metaphors can be true. Let me give you an example. I mean, it's true that we're coming up on Easter. Right? You accept the metaphor, it's true. I'll give you another example. We have a metaphor that time is a money-like resource. You waste time, spend time, invest your time, budget your time. Go around thanking people for their valuable time. How often do you thank someone for their time? Okay? You give someone time. So time is a money-like resource. Now, not only that, there are folks who want to extend this metaphor somewhat further. There's a corporate raider named Robert Half, runs Robert Half International, buys up companies, sells them off in pieces, fires lots of people, makes lots of money. And he had his folks, his efficiency experts, do a study of his employees, and he discovered that there was a tremendous amount of theft in all the companies he owned. In fact, what he discovered was that on the average, every employee steals from his company 4 hours and 22 minutes a week. They steal time, which is a non-renewable resource. He wants to pass a law against the stealing of time. Good luck. Won't happen, but it could happen. And if he succeeded, it could be true that someone was put in jail for stealing time. It would make that true. We have institutions that make it true that time is a money-like resource. We pay people by the hour and so on. We have lots of schedules. It makes time a money-like resource. This is not the case around the world. There are lots of cultures where time is not a money-like resource. For example, I have a friend, an anthropologist, Betsy Brandt, who studies the Pueblo Indians of northern New Mexico. She studies their language, and she's found out that in those languages, there are a number of different ones, there are no expressions for saying things like, I don't have enough time to do that. You can say, I couldn't find a path to it, but not I don't have time, not I wasted time, I spent time, I budgeted time. Just not there. Time isn't a money-like resource in that culture. And it's true in many cultures around the world. If you want to build a factory in a place that doesn't have a time as a money metaphor, you've got a problem. You might consider the people lazy. They don't think about it that way at all. They just live. Metaphors can be institutionalized, and when they're institutionalized, they can become true. It can be true that someone wasted an hour of your time this morning. Right? Anybody ever have someone waste your time? Right? It can be true. But time in itself isn't a money-like resource. Our institutions make it true. In science, we have metaphors that have entailments, that have inferences that we can test, where we can manipulate and do observations, and they can be more or less true. They can be pretty good. They can help us understand the world and still be metaphorical. So just because something's metaphorical doesn't mean it's true. It's not true. It can perfectly well be true. Let's take another example, mathematics. Mathematics is an example of a case where you have massive metaphor. Massive, incredible amounts of metaphor. All over mathematics. However, there's a mythology that it's all literally true. There are three types of metaphors in mathematics. One very boring, and two really interesting. The boring one is incidental metaphor. You write a step function on the board and you say, here are the stairs. Boring. However, there are really interesting ones. How do you understand what mathematics is? How do you understand arithmetic? Well, there are what we call grounding metaphors, metaphors that link it to your everyday experience. For example, what is adding? Well, there's one metaphor in which numbers are collections of objects, and adding is putting things in piles. You pile on more stuff. Subtracting is taking away. There's another metaphor where adding is creating a physical object. You put 2 and 2 together and you get 4. Or you take 2 from 4 and you get 2. Okay? So you can make objects. Numbers can be objects. Factorization is breaking down a number into its parts, its component parts. Then there's a metaphor that numbers are locations in space. So addition is taking steps in one direction. First I take 4 steps, then I take 3 steps. That's the same as if I took 7 steps. I turn around, take steps the opposite way, I'm subtracting. Okay, take 2 steps back, you get 5. So those are very basic metaphors. They don't go that far. You can't do a whole lot of arithmetic with it, but that's how you ground your knowledge. The interesting metaphors, the really interesting ones, are the ones in mathematics itself. The ones in which you understand one branch of mathematics in terms of another via systematic correspondences that preserve inferences, that preserve the facts about one domain of mathematics when you apply it to another. For example, consider the number line. As a metaphor, numbers are points on a line. Now, numbers don't have to be points on a line. You can do all your arithmetic operations with no points on a line. Just have numbers. You add, subtract, multiply, divide, raise the powers, no problems, no points on a line. Moreover, points on a line don't have to be numbers. In geometry, they're not numbers. No numbers in geometry at all. But if you have this magnificent metaphor, you can visualize equations. And you can write geometric figures as equations. And you can do all kinds of remarkable things with that metaphor. You get all of analytic geometry with that metaphor. Spectacular metaphor, but a metaphor. What about trigonometry? Anybody here take? Must be lots of people who took trigonometry here. Right? Who took trigonometry? We got a few. Lots. Wow, hey, great. There must be some high-tech firms in this area. There's a basic metaphor of trigonometry from which all of trigonometry follows. And it was constructed by Euler. Euler asked a very interesting question. He asked, how can you add angles? Now we all know, you got an angle, add them, boom, like that. That's what you mean. Euclid talked about the sum of the angles of a triangle is two right angles. How do you add angles? What's the problem? Addition is defined for numbers, not angles. Think about it for a minute. If addition is defined for numbers and not angles, somehow you got to get angles to be numbers. That's a job for metaphor. How do you get angles to be numbers? And Euler thought of this magnificent metaphor. He said, hey, we take a unit circle in the Cartesian plane. It is a circle, center at 0, radius of 1. And we put our angles in the middle of this circle with the vertex at 0 and one ray of the angle on the x-axis. And then we notice that there's a correlation. Here's our angle, here's our circle, and the angle cuts off an arc of the circle, and the length of the arc is in one-to-one correspondence with the intuitive size of that angle. So, we make a metaphor. The angle is the length of the arc. A right angle is pi over 2. 360 degrees is 2 pi because that's the length of the unit circle. Then you do this and you drop a little line. Here's the angle, here's the unit circle. You drop this line and that's the sine. This line's the cosine. And as you go around, you plot the length on another plane in Cartesian geometry, in Cartesian geometry, analytic geometry, which is defined by the metaphor that numbers are points on a line. And then you get periodic functions. And you notice something very interesting. When you go around once, it's the same as multiplying by 1. You get to where you were before. And if you go around halfway, it's the same as multiplying by minus 1. Do it twice, you get 1. So, Euler asked, what if you go around a quarter of the way? Well, if you do it twice, you get to minus 1. It's multiplying by minus 1, so it must be multiplying by the square root of minus 1. That puts I, the square root of minus 1, 90 degrees away from the real line. Ever wonder why it was 90 degrees away? It's a consequence. It's entailed by that metaphor. It has to be 90 degrees away. If you define geometry by that metaphor, there's no choice. Okay? Now, I won't go any more with this, but let me tell you where we're going. We're trying to understand my favorite equation, e to the pi I plus 1 equals 0, or e to the pi I equals minus 1. When I took high school geometry, I loved this equation. However, I understood the proof. I had no idea what it meant. And let me explain. E, 2.71828, ... I went to MIT. I know the expansion. Now they don't. They have calculators. They don't need to know the expansion. It's an infinite decimal. And it's raised to a power, pi times I. What does it mean to raise an infinite decimal to a power? Well, you're usually told that raising something to the power is multiplying it by itself a certain number of times. How do you multiply an infinite decimal by itself? Where do you start? Problem 1. How do you multiply it by itself a pi number of times, where pi is an infinite decimal? A funny question. How do you multiply that result by itself, the square root of minus 1 number of times, an imaginary number of times, and the answer is supposed to be minus 1? It is minus 1. Why? A job for metaphor. And in fact, Euler's metaphor will give you that. I won't go through it now, but it will. Basically, those results are metaphorical, and you can understand this a whole lot better if you look at the metaphors. But the metaphors are there in the mathematics. Now, the formal theory of mathematics, the thing that says mathematics is just a bunch of symbols in axioms, is what I learned when I went to undergraduate school. I went to MIT, I studied mathematics, and they told me, if you want to formalize an idea, you write it out as an axiom. Well, it turns out that the axioms are just symbols. There are no ideas there. I mean, they're just symbols. There's no, in the study of mathematics itself, mathematics does not study mathematical ideas formally. The ideas have to be studied by cognitive scientists. They're in your mind. They're not in symbols. Not only that, it's been proved. A shocking proof called the Lowenheim-Skolem theorem. The shock came early in this century. It was assumed at first that if you had an idea in mathematics, you could write it down in symbols, and the shape of the symbols, the shape of the formula, would capture the idea. If you did it in symbolic logic, first-order predicate calculus. Okay? That was the claim. So Peano formalized arithmetic with the natural numbers, and somebody came along and said, okay, hey, let's do the real numbers. Let's write down axioms for the real numbers. They wrote down the axioms that were supposed to characterize the real numbers, infinitely more real numbers than natural numbers. And it turned out that Lowenheim-Skolem proved that you could satisfy, you can make a model of those axioms with the natural numbers, not just the real numbers. That in model theory, in mathematics, you could satisfy any finite axioms at all with the natural numbers. Why? Because the axioms are written down in meaningless symbols, and the models have meaningless entities. And you can always satisfy a countable number of meaningless symbols with a countable number of meaningless entities. There are no ideas in axioms. Axioms have to be understood. What we're trying to do is start a field of the cognitive science of mathematics in which you understand what mathematical ideas are, and interesting enough, lots of them are metaphorical. Now, let's shift gears a bit. Metaphors are not just interesting for science. You see how much, getting there. They're also interesting for politics and morality. One of the most interesting things that Mark Johnson and I did when we were working on this book, Philosophy in the Flesh, was ask ourselves how we understand morality. We started looking at the metaphor systems for morality, and we discovered that there are around the world, so far as we could tell, about 20 different metaphors for morality. And they're in our culture. What do you think the most basic metaphor for morality is? Take a guess. Morality is accounting, called moral accounting. Think of it this way. We have a metaphor that well-being is wealth. We say, what are the costs of the earthquake if there's an earthquake? I live in San Francisco. They're always talking about when they say cost, they don't mean money. They mean human costs and other things. If I do you a favor, suppose I do something good for you, I increase your well-being, then you say, how can I pay you back? I'm in your debt. I owe you one. It's as if I've given you money. Now, suppose I do something bad to you. Then how can you balance the books? There are 3 ways at least. Actually, there are more. 1, you can pay me back in kind. Do something bad to me, called retribution. 2, I can do something nice for you. Balance the moral books that way, called restitution. Or you can take something good from me. It's called taking revenge. Okay? And that is moral arithmetic. That is, giving good is equivalent to taking bad. Giving bad is equivalent to taking something good. Now, or you can forgive the debt, called forgiveness. What is karma? Moral accounting with the universe. You do good things for people, the good things come back to you. You do bad things, they come back to you. What comes around goes around. Hey, moral accounting is out there in everyday life in this culture and most other cultures. Now, there are lots of other metaphors for morality. Let me give you a couple. Whoops, sorry. Hit this, that. Hit it again. One of the most interesting ones is moral strength. In this metaphor, being good is being upright, an upstanding citizen. Being bad is being low. Evil is a force in the world that can make you fall, bring you down. Bringing you down means you commit evil. So if you're going to be moral, you have to be strong enough to stand up to evil. Have a lot of backbone. Okay? What if you're morally weak? If you're morally weak, you're going to fall eventually, sooner or later. You're evil waiting to happen. It's evil to be morally weak, according to this metaphor. Now, look at this metaphor again. How do you get to be strong in the domain of physical strength? Do your push-ups, right? Discipline, jog, self-denial, self-discipline. That's how you get to be morally strong. If you're self-indulgent, forget it, you're going to be morally weak. Okay? This is an important metaphor. It occurs all over American culture. It's a very interesting metaphor. Let's take some others. There's a metaphor for morality in which immorality is disease. It's contagion. What follows from that? It can spread. You can catch immorality. Even worse, your kids can catch immorality. Who do they catch it from? Those immoral other kids. We better move to the suburbs. Put them in private schools. Let's take some others. There's a metaphor of moral boundaries. Something immoral is called a transgression or a deviation from the path. Immoral people are deviants and transgressors. Now, suppose you transgress, or you're deviant. You deviate from the moral path, the path of righteousness. It's not just that you've done something bad. You've endangered everybody else. Why? Because it looks like you've made a new path that other people can follow. You're a danger to society. You got to keep your kids away from transgressors because they can go along those paths. Right? It's important to remember that people reason, think in terms of these metaphors. For example, morality can be wholeness and immorality degeneration. The foundations of our moral system can crumble, can fall apart. And therefore they have to be shorn up and kept strong all the time. Okay, those are some of the metaphors for morality. Here are some others. Around the world, being moral is light and immorality is dark. It has nothing to do with skin color. It has to do with fear of the dark. And this metaphor usually goes along with another metaphor that says emotions are parts of the body. And they're different parts of the body in different cultures. So we have certain emotions in the heart. An evil person is black-hearted. In Japanese, where the emotions that you're not supposed to have are in the hara, or belly, an evil person is someone with a black hara, a black belly. In Hmong, where the emotions are in the liver, if you have a black liver, you're an evil person. And in Swahili, where the emotions are in the stomach, if you have a black stomach, you're an evil person. Around the world, same is true. There are others. Morality is empathy. What does empathy mean? It means you put yourself in someone else's shoes. You see what it is to be another person. Morality can be nurturance, helping someone else. Now, one of the most interesting metaphors for morality is that morality is happiness. Now, that's an interesting one. Why should morality be happiness? Well, think about empathy for a minute. Suppose you're an unhappy person. Would you want anyone else to be happier than you? Nah. You're not going to be very empathetic if you're unhappy. So there's a morality to being happy, because then you'll be empathetic and help people. Moreover, happiness is a gift you give to someone else. You don't want to be around grouches. Right? Morality can be happiness. There's a whole bunch of such cases. There's one in which morality is seeking self-interest. There you have a metaphorical version of Adam Smith's invisible hand economic model. The idea there in economics is that everybody seeks their own profit. The profit of all will be maximized. So since well-being is wealth, if everybody seeks their own well-being, the well-being of all will be maximized. And you get the Adam Smith economic version of morality. It's part of this culture. Now, during the 1994 election, I was watching lots of speeches, and I noticed that conservatives and liberals had different metaphors for morality. So I started writing them down. That's what linguists do. Made lots of lists. And I also, as I was doing this, got really puzzled. And let me tell you about my puzzlement. Linguists get puzzled about things other people may not get puzzled about. As a liberal, I thought that conservatives were irrational. And most other liberals I spoke to similarly thought conservatives were irrational. How could you be pro-life and for the death penalty? But being a good field worker, I talked to lots of conservatives. And they thought liberals were very irrational. How could you not want to put a murderer to death but sanction abortion? And as I made lists of irrationalities, for every irrationality in one column, I found an irrationality in the other column. Now, when a cognitive scientist sees this, he says, aha, there's a difference in worldview. Conceptual systems are differing. What accounts for these lists? So I wrote down the lists and the lists of moral metaphors, and I said, oh, okay, I'm going to worry about them. Then I found, hit it again. Then I found more things to worry about. Again, these are things only a linguist would worry about. I looked at the contract with America, bought myself a copy, and I got puzzled. And here's my puzzlement. I said, hey, look, these guys, there are some people who are against abortion, and the same people are for owning guns. What do these two things have to do with each other? And the same people who are in favor of owning guns are against the progressive income tax. What does that have to do with owning guns? And the same people who are against the progressive income tax are against environmentalism. And the people who are against environmentalism are against welfare. What do these things have to do with each other? Then I looked in the mirror and I said, I have the opposite views. What do my views have to do with each other? So I made more lists. And as I looked over these things, I got an answer. And it was very interesting. I noticed in many political speeches that the same metaphor kept occurring over and over. It was the metaphor of the nation as a family. We have founding fathers. We send our sons to war. We have Brotherhood Week, and so on. Okay? The nation is a family. The question is, what kind of a family is it? So I went to the family literature. I looked up stuff on families. It turns out that there are many kinds of families. There are 4 basic types. But the big ones that are politically and morally important in this country are 2 models of the family that generate and answer all of these questions. They are the strict father model and the nurture and parent model. Guess which is which? Now, what's in the strict father model of the family? In the strict father model of the family, who's boss? Father. Father knows best, right? Who knows what's right and wrong? Father. Who's the moral authority? Father. Who do you obey? The father. If the kids don't do what's right, if they do wrong, what does the father do? He punishes them. Otherwise, he's not a good father. In fact, he shows his love, tough love, by punishing them. Doesn't want to punish them. He loves his kids, but got to punish them. Moreover, in that model of the family, the strict father model, there's a view of the world. The world is a tough place. As Ollie North said, the world is a dangerous place. And he began his testimony to Congress and he repeated it over and over. The world is a dangerous place, and it is a dangerous place. Now, if the world's a dangerous place, what do you want your kids to be? You want them to be disciplined and self-reliant. And that is the most important thing, one of the most important parts of the strict father model. You want your kids to be self-disciplined, and you want them to become self-reliant. And how are they supposed to become self-reliant if they're self-disciplined? They become self-reliant by pursuing their self-interest. Those are the good folks. Those are the kinds of kids you want if you're a strict father. Now, when your kids become mature, they're supposed to have become self-disciplined and self-reliant. Do they live at home with you anymore? Till they're 30? Like in France or Italy? No. They're off on their own, 18 and out in some families. You know, you might help them with college, with a loan here and there, but fine, but they're on their own. And the parents cannot meddle. Now, where do you hear the word meddle? I'm a linguist. I look at where the word meddle occurs. It occurs with parents and older relatives, and it occurs with the government in conservative discourse. In the nation as family metaphor, the government is the parent, and it's considered a meddling parent for mature citizens who are self-disciplined, self-reliant, and the parent shouldn't meddle in their lives. Now, this is very clear in the discourse of Robert Dole. Last year, when Dole was still running the Senate, he made a speech after the Democrats defeated the balanced budget amendment by 1 vote. He was really angry, and he attacked the Democrats and the liberals, and he called liberals people who thought that Washington knows best. He kept repeating this on national TV. Millions of people heard, they think Washington knows best. Does that sound familiar? Blank knows best. Right? It's from father knows best. Is that a nice thing to say about Washington? No. It's not a nice thing to say about father either. It's about the meddling father who is meddling in the lives of his mature children who are self-disciplined, self-reliant, and taking care of themselves and know themselves what's right and wrong. Don't need Washington to tell them. The conservative views of government are coming out of that model of the family and that metaphor, and what the book Moral Politics does is show that the same is true for all the issues. What about the nurture and parent family? How does that work? Well, who's in charge of the nurture and parent family? Both parents. If there are two, both parents. What does a parent want to do as a nurturing parent? Well, he wants to nurture his children, and what does he want his children to become? Nurturers, to nurture other people. Well, how do you nurture someone? You've got to be empathetic. If you're going to nurture a child, you have to know what the child needs. So you have to have empathy. And if you're going to raise your child to be a nurturer, you have to raise your child to be empathetic toward other people, to think about what it's like to be someone else. In addition, can you be a nurturing parent if you're irresponsible? No, you've got to be responsible to be a nurturer. If you're going to raise your children to be nurturers, you've got to raise them to be responsible for other people. You have to raise them to be communally, family, and socially responsible. What else do you need to be a nurturer? You need social ties. You need to be connected to people in the neighborhood. If you're going to have your kid be in the soccer league, you got to know how to register. That's not easy. You don't always find out how to get kids in the Little League. Certain people know. You got to know who knows. Right? It's important to have social ties, especially if you want a babysitter. Now, what else is true of nurturers? They're very protective. How does a nurturing parent protect his kids? What does he protect them from? Well, crime, drugs, what else? Cars without seatbelts, cigarettes, alcohol, what else? Lead paint, pollution, inflammable clothing, all the things that liberals want the government to protect citizens from. To liberals, that's protection. To conservatives, it's regulation and interference. Why? It's interference with self-disciplined people becoming self-reliant by pursuing their self-interest. What's protection to one is regulation to another because you have different metaphorical worldviews based on the family. Now, I'm not going to go through this in any more detail. There's a whole book on it called Moral Politics. I believe one of the bookstores in the city actually has a copy. But you can ask for it, and it's not that expensive. It's pretty inexpensive. And it goes through all the details. And for example, it shows that there's not just one kind of conservative and one kind of liberal. There are lots of varieties, and it goes through what the varieties are and where they come from and what their views are and so on. And I won't bother you with all the details of that now. But let me finish up with one more thing. Let's turn to another important source of contemporary metaphor, the internet. How do you understand the internet? Well, there's the infamous information highway metaphor. There are actually two of them, and they're very different. The person who discovered this was Tim Rohrer, who's a graduate student at Eugene. Wrote a marvelous paper on it. What he showed was this. He analyzed Al Gore's speeches on the internet. And he showed that Al Gore puts together these two metaphors, blends them, mixes them. And he picked them apart. There's one metaphor of the information superhighway, which is a trucking metaphor. You get in your pickup, you go down there, you pick up that information, you bring it home and download it. Okay? There's another one in which the information superhighway is the highway to the future, to the information utopia, the bridge to the 21st century that goes over the difficulties. Okay? And they're very different, and Rohrer points out that they're different on issues of intellectual property. In the trucking metaphor, intellectual property is property. You're supposed to pay for it. Those programs you download are goods that you're going to buy and pick up. You're supposed to pay for all those things. They're commodities. However, in the metaphor that says we're going to utopia, information, computers are the vehicles that are taken there, and information is the fuel. And there are a lot of people who see the fuel as being those programs. And if you're keeping people from access to them, you're keeping us from getting to the utopia as fast as we can. The intellectual pirates who steal the programs, the hackers, have that metaphor. For them, intellectual property shouldn't be property. It's as fuel toward our utopia. It's a different meaning. They should all be free. Why are you stopping us from getting to the future by trying to sell these things as property through this other metaphor? Metaphors matter. They matter to people in those ways, but they matter in deeper ways. What's a website? How do you conceptualize it? Well, it's your home. It's a home page. Right? Why a home page? It's a home. Notice, a lot of people are homeless. Now, what kind of a home is it? Well, it's a home that you invite people into. What does that make you? Well, it makes you, for one thing, a host. And the people who come there are your guests. Now, if you have a home page, do you want it to be run down? Is this a hovel? No, this is an upwardly mobile home. You got to keep it well painted, cleaned up. And what does that make you? It makes you a homemaker. You've got to keep your website up to date, clean. You don't want, outmoded appliances and things like that. Okay, simple enough. What else does it make you? The home page is the self that you present to the world. The outer self, we have a metaphor that we have an outer self that we present to other people and an inner self that we keep private. The home page then becomes the self that you present to the world. Well, what kind of self do you want to present? You have to make a decision when you're doing your home page. What other metaphors does the internet have for us? How does the internet conceptualize us? What are you when you're using computer technology? Well, one thing that a lot of software companies want to do is help you. Help you to do what? Help you to become effective information managers. Think about that for a minute. You are an information manager. Right? Who in this society is an information manager? Well, there are file clerks, accountants, and there are very good people who love filing things and adding up numbers and keeping track of information. Is that what you want to be? Do you all want to be information managers? Is that your goal in life? Because you're becoming them. How many of you have more free time than you used to have? What parts of your life are you managing information in that you didn't used to manage information in? First, your email, if you have email. I've got 700 stacked at home to be filed. Next, your junk mail, of course. Your finances, everything about your home. Now you can keep track of everything about your home yourself. All of that information. Your vacation plans, your child schedule, your social engagements, your calendar, your relationship. You can keep track of the information in your relationships, your friends. What's happened is that you become more and more of an information manager. Now, maybe that's great. For many people, it is great, because computers can help you manage information if that's what you want to do. And sometimes you have to do it, and it's wonderful. But every time you do it, you get more information to manage. More and more information to manage until you can't manage anymore. Now, there are some people in this society who are wonderful managers, and I think they're terrific. We couldn't live without them. Really, I mean that. We couldn't live without these incredible people whose lives are dedicated effectively to being information managers. They're great. I'm not one of them. How many of you are great information managers? You don't have to raise your hand. Yeah, we got one. There are probably, several dozen, maybe 100 or 200 here. I suspect that more than half of you aren't. And I suspect that more than half of you don't want to be information managers. That is, the computer revolution has a metaphor for you that it is institutionalizing in this culture. And the more that you manage, the more you have to manage. It's called increase in productivity. Right? You are subject to increase in productivity. Do you want to be? If you don't, pick your favorite computer company, send them a postcard that says, I am not an information manager and I don't want to be. Any computer company that figures out how to make most people not be information managers will make billions. Because most people don't want to be. Now, there's a morality that comes with this metaphor. Suppose you don't manage your information. That's immoral. You don't answer your email. It's terrible. I sent you that message. Why haven't you answered it? It's been a day. You don't keep good records of your finances. You don't keep track of all your credit card expenses. All those little pieces of paper. You know, you don't have a program for keeping track of them. Or maybe you've got them in the wrong folder. All right? You're expected to have them. All those messages, you're supposed to save them in the right folders. What if you deleted them? You deleted my message? You've got lots of memory. You could keep my message. Now, what's important about this is that this is a morality that's well known. It's strict father morality. It says you're supposed to be disciplined and become self-reliant. This computer is going to make you a self-disciplined information manager and a self-reliant information manager, and that's good. To do that is to buy into that form of morality. It also will drive you crazy. Some of you. I mean, there's some of you who just love it, and that's terrific, and function well with it, and who believe in the morality. But if you don't, think about it, because it's happening. In general, metaphors matter. They matter because they change our lives. They matter because we live in terms of them. We think in terms of them. We do science in terms of them. And we run our marriages in terms of them. Think for a minute about the metaphors for marriage. These have been studied very extensively. And it turns out no two spouses have the same metaphors for marriage. Surprise. Let's take a few of the ones that are common. First, marriage is a journey through life together. What goes wrong with it? You're heading in different directions. Marriage is becoming a single person, the union of two into one. What if you want to be your own person? Something's wrong. Marriage is a partnership. What goes wrong with that? I'm doing all the work and you're getting all the benefits. It should be 50-50. That's what goes wrong with that. Then there are others. Marriage is a haven from the outside world. Marriage is a joint struggle against the outside things trying to get you. One of the most interesting ones that everyone has in some form is that marriage is a parent-child relationship with four versions. The husband is a father. Either he believes it or the wife believes it, with different entailments. The wife is a child, or the reverse. The wife is a mother, the husband is a child. Either the husband believes it or the wife believes it. Different entailments. That gets you into trouble. Ask any family therapist. It's a disaster. Do we have a family therapist? Has any of you ever used that metaphor? Notice it the next time you do. It's important to understand your own mind, your own unconscious mind. It's important to know when you're living your life according to metaphors, when you're having a fight with your spouse because you have different metaphors, when you're becoming an information manager against your will, when you're wasting lots of time, or you feel people are wasting lots of time and not just living your life. when you're budgeting your time and you don't want to be budgeting your time. You can't always change them, and some of them you can't change at all. You're not going to get time not to be understood in terms of motion. Doesn't happen. It's too late to change the time as a money-like resource metaphor for most of this culture. It's there, it's in our institutions. All you can do is go to Alaska and hide out. But not for long. There are some metaphors you might change. You might not have to be an information manager. It's possible that that could change. It's not too late. You should change marriage's a parent-child relationship, but that's one of the hardest ones to change. Very, very difficult. Again, any family therapist will tell you. But it's important to know these things. Now, so what? We think in terms of metaphor. What does this matter to what a human being is? I started out by saying there were three results I was going to talk about. Metaphorical thought, we've done that. The embodiment of mind, and the unconscious mind, the cognitive unconscious. What does that do to our concept of what a human being is? If you look at all traditional philosophies, their concept of a person is inconsistent with one or more of those results. For example, Descartes said that the mind is completely separate from the body, that reason is universal, and that we are defined by this universal reason, and that because the mind is separate from the body and not governed by physical laws, we have completely free will to think anything we want and do anything we want. It's false. The mind comes out of the body. We have a conceptual system, and that conceptual system is embodied physically in the synapses in our brains. When we have a concept that we use unconsciously, automatically, it's physically there. You don't change it. You don't just say, oh, I'll stick this other one in. It's not so easy. What that means is we can't think just anything. We can only have the concepts that our bodies give shape to. We can only have the metaphors that our experience as human beings allow. We can only have the freedom to do something that we can imagine. And our imagination has lots of possibilities, but it also has limits. It's important to know what those limits are. But we are not what Descartes thought. We're not what Kant thought either. Kant thought that reason was universal, independent of the body, transcendent. It transcends the body, and that morality came out of universal reason. That morality was universal, and that if you could just reason properly, you would know exactly what was good and bad in every situation. It's false. We have different metaphors for morality. Many of us have opposed conceptions of morality. Those other guys who have that other irrational morality have a conception of morality. You have to understand what it is, what your neighbor is thinking. And you have to understand what you're thinking. Not only that, we don't just have one. Most of us have both the strict father and the nurturant parent models in different parts of our lives. I have lots of friends who are liberal with respect to their politics and are strict fathers in the classroom, who want rigor, discipline, competition in the classroom. Right? There's some who don't. There's some who want cooperation in the classroom. There are different ways of teaching depending upon our metaphors, and that has to do with morality. There isn't a transcendent universal morality. We're not that kind of being. Where does our metaphors for morality come from? Well, we've looked at this in some detail. If you go down the list, take things like morality is health, immorality is disease. It comes from physical well-being. You're better off if you're healthy than if you're sick. Moral strength comes from you're better off if you're strong than if you're weak. Well-being is wealth comes from you're better off if you're rich than if you're poor. Morality is empathy comes from you're better off if people empathize with you than if they don't. And so on. In short, the conditions for human well-being, physical and social human well-being, give rise to our conceptions of morality. They're embodied. They come from the fact that we have bodies. Morality does not transcend the body. Kant was wrong. Take the view of a person whose mind is a computer, where the mind is computer software, which happens to run on human hardware. It's false. Our concepts are not independent of our bodies and brains. They come out of and are shaped by our bodies and brains. Meaning is not independent of that. And that's important. And at this point, I'd like to thank you.